Hi guys, so let's discuss today's Leetcode challenge problem, that is 2457 lead minimum additions to make integer beautiful. So you are given two positive integers n and target, and integer is considered beautiful if the sum of its digits is less than or equals to target. Return the minimum non-negative integer x such that n plus x is beautiful. The input will be generated such that there is always possible to make n beautiful. Okay, so basically we have been given a variable n. We have been given a variable n and a variable target. So in the given example, the target is equals to 6. So we have to add a variable x such that x is greater than or equals to 0, and then sum of the digits. Basically, the sum of the digits should be smaller than or equals to the target. So let's first understand with the current example that is given 16. So if we calculate the sum of the digits of this number, that is a 1 plus 6 is equal to 7. Okay, so the sum of the digits is equal to 7, that is greater than target value, that is given 6. So we have to add a value in n such that it will become smaller than target. So what we will do, I will start by adding one by one value. So let's say I add plus 1 is equal to 17. If you calculate the total sum of this value, it comes out to be 8. So it is still more than that. So let's say I will add plus 2 here, 16 plus 2, it is equal to the 18. Okay, so now it becomes 9 here. Now let's add one more value, it is 3. And now what will the sum we are getting? Now we are getting the 19. And what is the sum of the digits here? Sum of the digits is equal to 10. Okay, so sum of the digits are increasing. Now let's add 4 here. So if we are adding 4 here, we find out that the sum of that total sum is equal to 20, and sum of the digits is equal to 2 here. Okay, so in this way, the minimum value of x that we need to add in our answer, so that the sum is equal to, so that the sum of the digits should be smaller than or equals to target is 4. So the value of x is 4, and it is equal to the answer that is given. Okay, so let's take one more example, that is 467, and the target is equal to 6. Okay, and the output that is comes out to be 33. Okay, so let's discuss this problem, this example also, 467 and 6. So now what I will do, I will return on this example 467, and the target value is given is equals to 6. So one thing that we can easily observe, that by adding the value in our variable that is given in n, if we add a value in here, it will continue to increase until a point arises when we are getting the 0. So basically, I add the value in this 7 such that it becomes a 0 here. That means I make a carry here in another position. So what I will do here, I will add 3 here, since we know that sum is already greater than the target. So what I will do, I will add 3 in 7. If I add the 3 in this position, I will get a 0 here. So initially there are 7 sum that it is contributing. Now it is contributing nothing, but 1 is also get carried here. So if 1 is carried here, it will equal to 8. Okay, now the final currently it will total output will be equal to the 480. So if 470. So by adding a value here, what I mean to say, if I add a value plus 3, what we are getting? We are getting 470. Let's calculate the total sum of the digits here. The total sum of digits is 4 plus 7, it is equal to 11. So we have improved in our total answer. Now let's repeat the same thing with the next digit, that is this 7 digit. Let's add 3 here in this position. So I will add total of 30 in this position, the total. So if I add 30 here, the output will be equal to the 500. Okay. Now let's calculate the total sum of the digits here. That is come out to be, it is going to be 5 plus 0 plus 0, it is equal to 5. It is smaller than target, is more than equals to target. So we the minimum value of x is come out to be 33. So if we are able to easily observe that, what we have to do basically to get it our answer, let's say let's understand with this problem again. So we have been initially given 467. We first calculate the total sum of the digits that is given. Sum of the digits that is comes to be very large here. It is come to be 17. So if it's very large here, so what we'll do, we will iterate from the left. We will go start our iteration from the left, and we find out the first non-zero value that is come out to be 7 here, and we make it 0. So making it 0 means that we are adding a value x here, such that it carry 1 in the next position, but its turn out to become 0. So because it is the only possible way to reduce the sum of the digits. So if I add 3 here, it will carry 1 here, but it will decrease its value to a low extent. So if it's carry here, the current output will be 470. We find it out in our loop and try to get the some new sum that we are getting in the new digit. So if we find out that it is come out to be 11. So what we will do, we will repeat the same step again. We will find it, we iterate and find out the first non-zero value again. So this first non-zero value again is now to be 7 come out here. So what we will add the value in to the 7 such that it carry ones on the next position and becomes itself as 0. So the new sum is comes to be 500. We recalculate the total sum of the digits here now. If we recalculate the sum of the digits now, it is come out to be 5. So while checking in our while loop, we also check whether it is greater than or equals to the target, or greater than the target, or smaller than the target. So now the value is smaller than the target, so it means we got our answer, and we will store this value in a result variable, and this total answer will be equal to the 3 plus 30, that is equal to the 33. Okay. So let's understand the solution of this problem. So basically what I will do, I will create a variable x here that is equals to the 0, and for each iteration I will use the digit sum. Digit sum is basically finding out the sum of the digits of this. If we can see here, so we take the variable n here, and while n is greater than 0, we find out the sum of the digits of its value. Let's say 467 we are first giving here, right? So if 467 is given, how it will iterate, it will get a modulus of its with 10. If I modulus of this 10, I will get 7 here. So the 7 basically is added in our result answer, and now what I will do, I will divide this value with 10. So if I divide this value with 10, it comes out to be 46. Now I will repeat the same step again, and now I take the modulus of 6, that is equal modulus with 10 again, and it's comes to be 6, and store store in the result variable this value, and then I will divide this value 46 by 10. It is come out to be 4, and repeat it again. So in the next iteration, the value will equals to modulus by 10 is equal to the 4, and by dividing it by 10 it comes out to be 0. So we exit from this loop in our third iteration. So in the result, and the result will store the value 4 plus 6 plus 7 is equal to the 17. Okay, in our first iteration. Now the first iteration is completed at all. It's after checking its value whether the iteration is completed or not, it will we will check it our value here, that whether digit sum is greater than or smaller than our target. If it's come out to be greater than, that is come out to be 17 in our case first. So it's come out to be 17. It is greater than 6 in our example. So we basically normalize this value. So normalization means that the 467 is given, I will go from the left to right and find out the first non-zero value and add a value to this non-zero value such that it becomes 0 and carry a value to the next position. Okay, so now what I will do, this is let's see, understand the normalized variable function. So I will create a variable value in a temp here. So what the temp will do, temp basically store the value of n and for our iteration basically. So in our iteration, what I will do, I will modulus 10, while modulus 10 is equal to 0. So basically if an example is given, let's say 0 0 0 0 0, so it will basically eliminate all the 0 that is coming our way, so that we get our first non-zero value when we iterate from the right to left. Okay, so we can now understand how we are proceeding. So when we are getting this value, we basically divided 10 by 9. So it will, in the first iteration, what it will do, it will eliminate the first value. It eliminates the first value. In the second iteration, it eliminates the second value. In third, in fourth. Now in our fifth iteration, we find out that the 7 is a non-zero value, so it will loop out from here. So take out from this while. While we are doing this, we also store the total, basically the power of 10 that we are basically increasing. So value will basically increase its value because let's understand with this example again. 467 0 0 0 0. So since we have to add the value here, so in our first non-zero value, so it will look like this. Okay, so for all the zeros that is coming before it, we basically have to add as 10 to the power. Okay, so this is what we are doing here in this step. So value will store the total power of 10 here. After we are storing this value here, so we are now at a position of 467. Now our final result is the temp variable is storing the 467. So we have to add a 3 here, right? So what I will do, I basically do, I know this variable, I know this value, and to get that value that will give 0, we have to do 10 minus 10 minus 7 basically. So how 10 minus 7 is coming? 10 minus 7 is coming, since 7 is the least significant value currently. So what I will do, I will do 467 by modulus of 10 and it give me the 7. Okay? And after getting the 7, I will do 10 minus 7 and I will get the 3. Okay, so after getting the 3, I will get multiplied it by value. So basically what I am doing here, currently the value is equal to 0 0 0. That is, we are finding it out here. So it will after, and I get the value 3 from this value. So I will multiply it by 3 and I will get the result. It is equal to the 3000. And this is what we needed. Okay, so this is what we needed for this value, because what initially the value is 467 0 0 0 0. Now we are adding this 3 0 0 0 0. Just calculate the result is 0 0 0. It carried this one 480. This is what we wanted, right? So I will do this like this, and I will increase this value, our n to this value, and the n will equal to the 48000, right? And 0, right? And I also return this variable to the value n. While doing this, I basically have passed the n as a reference value, so it will update the original n value that is I am sending it here, right? In this way. Also since our answer need to store the value which we have added it here as a minimum in the x value, so I will store the 3 0 0 0 to our resulted x value. Now if you repeat this again and again, we will get to our final answer. let's do one thing. Let's try to submit the solution now. Run the solution. Okay, so we're getting the correct answer. Now let's submit this. Yeah, so we are getting accepted. So that's all for this video, guys. I will share the link of this code in the description section also. Thank you for listening to this video, and bye.